So this is a short tutorial on how to stack Seestar images in Siril 1.2. Firstly, you need to have transferred your sub-exposures from your Seestar. What you'll end up with is a JPEG image showing the stacked image from Seestar. You'll have the stacked fit file, and then in another folder you'll have a whole series of sub-exposures. In my case, I've got 600 of them, and they're in a folder that's appended with -sub. So the first thing to do in Siril is set our home folder, and I generally set up a completely separate folder from where the Seestar subs are saved. And then I've got it in a folder called Seestar, and then for the tutorial I have a tutorials AGC281, and I create a folder in there called process, and I make that the home folder. So what we're now going to do is convert our Seestar sub-exposures into a Siril sequence. So we click on the plus, we go to where those sub-exposures are saved, which in this case is NGC281, and in there you'll see there's a folder called NGC281W-sub, and in there we select Control A to select all of them and add, and that's added the list of all of those lights into our list to be converted. Down the bottom we select Debayer and give the sequence a name, typically light, and click on convert. Now all this is doing is taking the original FITS files, it's debayering them, i.e. it's taking the color data out of the single image. So you'll see it goes through and it converts 600 odd sub-exposures into a format for Siril. You can look at those and see a bit more detail if you select auto stretch and unlink, and these are our 600 sub-exposures. The next thing we need to do is register these. If you click on the sequence tab, you'll see it's selected the light.sequence sequence. If we go to registration, and I keep all of the default settings as they are, and click on go register. Now what this does, it selects lots of stars that it's now going to align each image to, and as it goes through that, it reads all the 600 files, and now that's just about finished. So that's now aligned all of the images. You can see this final image shows the field rotation. The next thing I like to do, which is probably the most important step, click on the plot tab, and you'll notice that this is showing the sort of the quality of each image. And you'll see I've got some that have got a very bad quality figure. A high number means bad quality. So what I like to do is go through and remove those from the sequence. So down at the bottom here, there's a box to show the list of all of the images. So we'll make that a bit bigger. And I like to sort this list by FWHM, because that then shows, in general, the best images at the top, and then as we go down, the worst images. If I go all the way to the bottom, this is where we start seeing bad images. And if we go through, there's a particularly bad image, and another bad image there. So it's up to you. You pick what you believe a bad image is, and you can use the space bar to deselect them. And I'll deselect all these particularly bad images, and I'll keep the rest. In theory, you should go through all of them. There's another bad one, for example, and look for bad sub-exposures. There's another. That's got all the stars have been doubled. on that image. Obviously there was a bit of wind that blew the telescope. So as I say, you can go through, pick as many as you like, depends how thorough you want to be. I'm not going to do all 600 here now. So we've now excluded the images that we don't want to include. And we now go to the stacking tab. On here I use average stacking with rejection, additive with scaling, and I select output normalization and RGB equalization and start stacking. This will read all the sequences that we haven't, all the sub-exposures that we haven't excluded from our sequence, and we'll now align those stars and stack the images on top of each other to generate as good a signal to noise ratio as is possible. It's now doing the stacking. You'll see the progress bar going along the bottom. And there's our final stacked image, which looks pretty good. That's been saved as R light stacked. Now that we've done the stacking, I like to change the home directory and come out of the process directory and just use the basic NGC281 directory. And then I can then save that stacked image in here, and I will call it NGC281. And that's now saved for us to work on. The final thing I like to do, image information, image plate solver, because Siril ends up making the image upside down typically. So we run plate solver and this will check the alignment and you'll see it actually flips the image. And that's our image ready for post-processing. We'll save that, and that's the end of this tutorial.